Let us make a detour in the discussion on the assessment of estimated parameters and talk about a situation when you have two estimates and with each one with a different variance. And I have to tell you that these tests can be treated as a general test in which these estimates may be also mean values computed from two different samples. So what we want to do then is, well, apply this expression as given in here, and let's just look at the different terms. We have these mean values or estimates, x1 and x2. I'm using the bar to represent them. We have the mean values, the population mean corresponding to these two estimates. Okay, and essentially our null hypothesis is that the mean values, the difference of the mean equals to 0. So in practice, we can consider this term here equals to 0 already. So which means that the expression, even though I'm going to write down the expression with the difference between the estimates, these would represent sample and quantities derived from samples. And here we have these quantities that mu, which represent the population. But ultimately the second term will vanish to 0. And the denominator is basically the square root of the populations and deviations divided by n. N would be the sample size. So what we are going to do is we're going to compute the statistic y, which is given by the expression, and we're going to test if that statistic is less or equal to a threshold value that we're going to draw from the normal distribution. This is the standardized normal distribution, and having a particular 1 minus alpha confidence level. So if y is less than the threshold, then the null hypothesis will not be rejected. And now there are some variations in this test. If population deviations are unknown, we can derive the standard deviations from the sample. In this case, you are going to use the tau distribution. So the statistic now is going to be computed using a tau distribution. This is the number of degrees of freedom and 1 minus alpha confidence level. And if S is derived from another sample, we are going to use then the student t distribution. So here now is the test. Again, the statistic y less or equal the threshold value that is will be determined from the student t distribution with new degrees of freedom 1 minus alpha confidence level. The degrees of freedom will be computed by this expression here, which is a combination of sample variances and the number of observations. Also other variations. What if the population variances are equal? So the variances for the two quantities, they are the same. So we're just going to call them sigma. So this statistic now, the denominator is slightly different, but we're still going to get from the threshold value will come from the normal distribution. because we have the population variances. If the population variances are unknown, so we are going to either use the tau distribution or the student t. So which means that we are going to test, no, this is wrong. So we are going to test, so we test y using either tau or the student t distribution as before. Okay, so here is the expression for the test using the tau distribution, and here the test using the student t distribution. Number of degrees of freedom will be computed by this expression here. So that's the end of the tour. Just a add-on here, or a test that can be applied to any, basically to any quantity, including estimates.